Hello class, this is lesson 11.2, proving figures are similar using transformations. So in this lesson you're going to be given two figures and then you're going to have to apply the definitions of similarity and similarity transformations. Some of these transformations we covered actually in Geometry A. If you remember, we talked about reflections, rotations, translations. So you're going to be seeing those rules again in this lesson. This is a short lesson, but you are going to have to remember how to apply those transformations. So to start off, what we're trying to do is we're trying to map a pre-image to its image or an image to its pre-image. So what we're pretty much trying to do is, if you look at these examples, we want to find the rules where we could get this image to become this image, either through a reflection, a translation, a dilation. So now that we know how to handle each of those transformations, we could actually look at certain objects and see what the rules are going to be. We are going to have to use a coordinate notation in this section. If you remember that from the previous lessons, coordinate notation is where we have a point x, y, and then what we do is, if we have a dilation, we use a multiplier to each x and y. This is an example of a rotation. So xy becomes negative x, negative y. And then this is an example of a reflection across the y-axis. Now, I don't expect you guys to remember these rules. I am going to be attaching a document, a cheat sheet that shows all of these rules summed up so that you guys could refer to those as you guys are doing the problems. Okay, so let's get started. So we're going to start on page 14. Okay, and just like I said, we're going to recall the four transformations. So a reflection, that's when a transformation that uses a line like a mirror to reflect a figure. A translation, that shifts all points in one direction, so either moving to the left, to the right, up, or down. A rotation is where we could either go clockwise or counterclockwise, and this is what we talked about in lesson 11.1, dilations. This stretches or compresses a figure vertically or horizontally, depending on what the scale factor is. Okay, so let's walk through one example. So let's do the first example. Find a sequence of similarity transformation that map the first figure to the second figure. Now they say AB DC to EF GA or EF HG. So AB DC to EF HG. So this is we're starting here and we want to end up here. How can this figure end up as this figure? Notice that this figure is bigger than this figure, so what's occurring is a dilation with a scale factor that is between 0 and 1, because we're going from a big to small image. And then what's also occurring is some kind of translation. We're moving this object so that it gets down here. So to start off, we're going to do this in steps. So we identify the transformations. We say it looks like it's a dilation and it looks like it's a translation. Next, we want to find out what is the scale factor. What is the actual scale factor of the dilation? And to do that, what we're going to be doing is we're going to pick a side and we're going to count the length. So if we look at from C to D, that is 1, 2, 3, 4. From G to H, that is 1, 2. And then on the side right here, let me write, remember the scale factor is equal to the image over the pre-image. So GH over CD So we say it's 2 over 4, and then that reduces to 1/2. Okay, so next, now they don't show this step here. The next step that I'm going to be doing, what I'm going to be doing next is I'm going to be looking at each of these points, A, B, C, D, and I'm going to use this bottom space for room. So A, B, C, D. And then I'm going to find out where these points are located. So point A is located at 1, 2, 3, 4, 5, 6. So that's going to be at 1, 6. Point B is 5, 6. Point C is -2, 2. Point D is at 2, 2. So these are my original points, A, B, C, D. And then what I'm going to be doing is I'm going to be using this scale factor 1/2 to find, I'm going to call my prime points. So I want to say A prime, B prime, C prime, D prime. So what I'm going to be doing is I'm going to be multiplying each X and Y by 1/2. So I'm just going to show my work. 1 times 1/2, comma 6 times 1/2, 5 times 1/2 time comma 6 times 1/2, -2 times 1/2, comma 2 times 1/2, and then 2 times 1/2, comma 2 times 1/2. Now these points end up becoming so 0.5, comma 3, 2.5, comma 3, -1, 1, and then 1, comma 1. And then let me plot those points on this graph. So 0.53 is here. That's my A prime. 2.53, 2.53 is here. That's my B prime. -1, 1. So -1, 1 is here. That's going to be my C prime. And then 1, 1 is here, and that's my D prime. So you see that we shrank this image by 1/2. Now that we're on the same size as this image, all we have to do now is count to see how much. Let's focus on a point. Let's focus on D prime to H. How do we get from D prime to H? Well, what we do is we move 1, 2, 3, or actually 1, 2 to the right, and then we move down 1, 2, 3. So let me kind of zoom in so you can see that a little bit better. So here's D prime. We went 1, 2, and then down 1, 2, 3. So if we move 2 to the right, that is like we're adding 2 to X. And if we go down 3, that's like if we're subtracting 3 to the Y. So let's actually look at the solution that they gave us. We did this step. XY becomes half of X, half of Y. And then we said that XY becomes X plus 2 because we went 2 to the right, and then Y minus 3 because we went down 3. Describe the transformation in words. So dilation with the scale factor of 1/2, followed by a translation 2 units to the right and 3 units down. That's how we're going to answer this question. I just want to say that this part here was just the middle step that we needed to use to find the middle object, because to get from this pre-image to this final image, we actually need a middle intermediate piece, and that kind of helps us find out what the translations are. Okay. Let me see. Next, let's look at this example here. We want triangle JKL to triangle PQR. So let's look at JKL. Now, JKL is facing this direction, and PQR is facing this direction. What's also occurring is that we're going from a smaller object to a bigger object. So we know there's going to be a dilation, and we also know there's going to be some kind of rotation or transformation that's occurring. Let's start with the dilation. So I would pick a side that is straight. So if you look at JL, JL is equal to 1, 2, 3. Now the side that corresponds to JL is going to be PR in the big object. So let's look at PR. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. PR is 9. And remember, to find the scale factor, we do the image divided by the pre-image. So we do 9 divided by 3, and that is 3. And that's why they went from xy to 3x, 3y. So the first thing they did was they multiplied each point by 3 to enlarge the object. So let's kind of do this. Try to do it right here. We have J, KL. J is at 0, 1. K is at 1, 2. And L is at 3, 1. Then I'm going to say J prime, K prime, L prime. So what I'm going to do is I'm going to multiply each one by 3, and I'm going to have 0, 3, 3, 6, and then 9, 3. And I'm going to plot those points. So 0, 3 is here. 3, 6 is here. And then 9, 3 is here. So you see you have this dilated object. And now to get from this orientation to this orientation, I'm just going to tell you it's going to be a rotation of 90 degrees counterclockwise. So if you imagine this object gets flipped, and this is the rule that we're using for that. So what I want you guys to do is I want you guys to pause the video, and I want you guys to match these graphs to these statements. There are 3 graphs and there are 4 prompts, so one of them you're not going to use. And then press play to watch or to look at the answers. So let's look at the first problem. Map PQRS to TUVW. So here is PQRS and here is TUVW. Let's look at a side and let's try to find the scale factor for this one. So what I'm going to be doing is I'm going to be looking at side P, or let's look at QR. QR is 1, 2, 3, 4, 5, 6. Then the side that corresponds to QR is UV. So here, UV is 2. So my scale factor is going to be the image, so UV divided by the pre-image, and that reduces to 1/3. So then if we look at these options, which one has a scale factor of 1/3? And that is A. So this would actually be A. So it's multiplied by a scale factor and then a reflection. Okay, let's look at number 2. And let's start with the scale factor. So let me pick a side, AB. Well, we're going from ABC to DEF. AB is 1, 2, 3, 4. Then DE is 1, 2, 3, 4, 5, 6. So, and then we're going to go from, we're going to find the scale factor is DE, 6 divided by 4, which becomes 1.5. So which one of these has a scale factor of 1.5? And that is C. So you can map by a rotation about the origin 180 degrees, followed by a dilation of 1.5, translation 3 units to the right, and 1.5 units up. So this is going to be C. And the last one, okay, so the last problem, we have ABCD maps to EFGH. So we're going from this smaller one to this bigger one. And then if we focus on, let's focus on this side, AB. AB is equal to 2. And EF is 1, 2, 3, 4. So then my scale factor is going to be EF divided by AB. So we're going to have 4 divided by 2, which is 2. So if we look here, this one has a dilation of 2. So you can map by reflection across the x-axis. That's what's occurring. This is reflecting. And then a dilation of 2. So that would be B. And that pretty much covers this lesson. And let's look at a homework problem to help you guys out. So for lesson 11.2 homework, you're going to have some problems where you have to choose the transformation that occurs, and there's some that have a combination of transformations. So you're gonna actually select more than 2 answers. Let me help you guys out with problem number 3, just because I think that one looks the most challenging. And let me zoom into that problem. Okay, so for problem number 3, it says which combination of transformations below best describes the changes from KLMN to GHIJ. So we're going from this pre-image to this image. Now by looking at this, we know that the scale factor is going to be between 0 and 1. It's going to be a fraction because we're actually going from a big image to a small image. What we also know maybe is that if we look at the length of GH is actually the same as the length of MK. So what we actually know is that this actually rotated some way. So instead of it being up like this, it actually is going to go like this. So let's look at our options. A rotation 90 degrees clockwise with a scale factor of 3. Well, we said that the image was shrinking, so we cannot have a scale factor of 3. It has to be a fraction, so it can't be A. Rotation 270 degrees clockwise and a scale factor of 3. So again, because of the scale factor 3, it has to be C. Now, when you guys are doing the homework, make sure you guys are doing the homework on the PDF through Kami, and you could actually select the box that you say is your answer. All right, guys, have a good day.